Here's our scenario again, where we have the derivative of an unknown function, some matrix times the vector of unknown functions again. What we'd like to do is show that there are solutions to this and that we can demonstrate those solutions. And we will verify in the same way we did before. We'll figure out the differential equation here. And what we're going to do is plug in our solution into the left-hand side of the differential equation and see what we get. Then we'll plug into the right-hand side, see what we get, and if they're the same, then by what we mean by an equation, we have a solution that satisfies the equation. Now the verification step here in some ways is easier than it used to be. The left-hand side is just the first derivative of our x1 here. We said this is our x1, so we take the derivative, and it'll be element by element of e to the 2t. And that will be a collection of 2, 2, and 2 e to the 2t. And if you want, you could write this out as 2 e to the 2t times the vector 1, 1, 1. Sometimes it'll be helpful to write it this way, other times it's tidier, I think, to write it that way. Just know that both are perfectly equivalent because we can multiply this in and we would get that vector there. Looking at the right-hand side, we have our matrix 0, 1, 1, 1, 0, 1, 1, 1, 0, and times x of t, which we just said was e to the 2t, e to the 2t, and e to the 2t. So we're plugging this solution into here, then taking the derivative. We're also plugging it into here on the right-hand side. And if we do our matrix multiplication, we're going to end up with, on the first row, we're going to have e to the 2t plus e to the 2t. On the second row, we'll have e to the 2t plus 0 plus e to the 2t. I think you can see where this is going. And then we'll have e to the 2t plus e to the 2t plus 0. So I'll have 2 e to the 2t's. And just saying that out loud made it real. We'll have 2 e to the 2t's times 1, 1, and 1. And these are equal. And so we get a check mark. Notice here we have two more solutions, and we're going to do exactly the same procedure. We're going to compute the left-hand side of our differential equation here. The left-hand side is that. The right-hand side is this. If this is our proposed solution, then we're going to take the derivative of negative e to the negative t, 0 e to the negative t. And that will be, when we're done, if we differentiate, we get two negatives, so e to the negative t with a positive out front of it, a 0, and a negative e to the negative t. The right-hand side is this matrix, 0, 1, 1, 1, 0, 1, 1, 1, 0, times our proposed solution. So again, this is being used in both places here where x occurred. We plug it in here, and what we get is 0, 0, positive e to the negative t, then negative e to the negative t, 0, positive, that ends up canceling. So that's going to equal 0. And then the last one is negative e to the negative t, 0, and 0. And so that, what are we comparing to? To the final value of the right-hand side and left-hand side. These are equal. And so this is a solution. x2 is a solution. Notice this is not obvious that this would be the particular combination of this exponential with this negative and positive arrangement. We also see a different arrangement here, which is interesting. Let's just make sure it works as well. We're going to take the derivative of this vector. So 0 e to the negative t, negative e to the negative t, and that's going to give us 0, negative e to the negative t. This will be a double negative, or positive e to the negative t. For the right-hand side, we repeat our same procedure as before. It's made up of the matrix 0, 1, 1, 1, 0, 1, 1, 1, 0, And then we're going to use our solution for this test, 0 e to the negative t, negative e to the negative t, and that's going to give us 0 e to the negative t minus e to the negative t, so 0 again. The next one we're going to have negative e to the negative t, and the last row will have 0 and positive e to the negative t. We compare the left-hand side and the right-hand side, these things here, and lo and behold, these are equal. Big check mark. And so x3 is a solution. So now we've verified that there are 3 solutions that we can find, or that can be given to us, and the verification procedure is the very simple thing of plugging them in and making sure the left-hand side and right-hand sides equal one another. Once we have those 3 solutions though, then we can write out our general solution. Whatever behavior x of t has, it's going to be a linear combination of that e to the 2t stacked together, or possibly some e to the negative t, with the negative out front, 0 e to the negative t here, plus c3 times this vector, e to the negative t, negative e to the negative t. And this is all that can be found in the solution. It's going to be some linear combination of those 3 solutions. So an exponential growth, an exponential decay, another one, and in certain ratios. So we're going to explore this as we continue through the course. What does it mean to have these different terms and different structures? But at the end of the day, it's very similar to what we saw before. Find a solution, a second and a third. The general solution is just the linear combination of those with some arbitrary constants in front of each term.